What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at completing the square again, but specifically we're going to be looking at odd numbers as that middle term in our quadratic. The maths that we've learnt is almost exactly the same, but things just get a little bit uglier, and so we just need to be completely on top of our skills in order to not get distracted by these harder numbers. So last lesson we learnt how to complete the square with those even numbers, and there is one major trick. We're always looking to create a perfect square out of nothing by adding and subtracting half of that middle coefficient term. Just really quickly, I have made a little bit of a mistake in this video with my language. When I say you've got to add and subtract half that middle value, I definitely mean half and square. So if it's 6, half of it is 3, squared is where that 9's coming from. So anytime you hear me say plus or minus a half, I mean plus or minus a half squared. So if we've got something like x squared plus 6x plus 11, all we need to do is add and subtract half of that 6. So we plus 9 minus 9, that's nothing. We haven't actually changed the whole quadratic, but now we've got something that we can factorize at the front and simplify at the back. So if I've got x squared plus 6x minus 13, all I've got to do is plus and minus 9 in order to create a perfect square at the front, and then I'm just going to have to simplify the back. Again, I've added nothing. So this becomes x plus 3 all squared, and then minus 22 at the back. The maths for this is not too bad. The idea is a little bit complicated. We probably haven't seen something like that before, but the maths is not too bad. So why is it harder with odd numbers? Literally just the whole thing looks uglier. There's some fractions or decimals, whichever your teacher wants, and they just kind of fly around everywhere. So we need to make sure that our scaffold is strong enough in order to not get distracted by these more difficult numbers. So if I've got something that looks incredibly similar, I've got x squared plus 9x minus 11, I'm going to have to plus or minus half that 9 value. So what I'm actually putting in is x squared plus 9x plus 4.5 squared minus 4.5 squared minus 11. Because we want to use those bigger numbers, we could even do that expanded out. Instead of 4.5 squared, we could turn that into its actual value, which is 20.25. But this doesn't really look like a perfect square, at least not one that we're used to seeing. But because I halved it and squared it, I know for sure it is a perfect square. So that means that my factorization of this front part of my quadratic is still really simple. I just have to use half of 9 or 4.5, so I've got x plus 4.5 all squared. So then I just have to simplify that last term, which gives me 31.25. And now I do have a difference of 2 squares that I can do. Because that first term is just x plus 4.5, I can use that in both of my difference of 2 squares, and I'm just going to use root of that last value. So this in one bracket is x plus 4.5, that would go into both, plus or minus root 31.25. If you're not 100% sure how I got to that step, please look at my video about difference of 2 squares, and it also comes up again in my last completing the square video. Some teachers do like it in fraction form, so we're going to do that in this example. So I've got x squared plus 5x minus 8. So here I've got a half and then square the value that I'm going to add in. So I'm going to do x squared plus 5x plus 5 divided by 2, that's the half, all squared, minus 5 divided by 2 all squared, minus 8. If I do actually want to square these out, I've got x squared plus 5x plus 25 over 4 minus 25 over 4 minus 8. And the perfect square that I've made at the front would just give me x plus 2.5 all squared. Again, just half of that middle term, that 5. I would definitely just use a calculator to simplify this last bit, but if you do not have a calculator for this type of test, we do know that 8 is the same as 32 over 4, and then I can minus 25 over 4 minus 32 over 4, which gives me minus 57 over 4. Now my answer for this one would be x plus 5 over 2 all squared minus 57 over 4. Again, if you do have to find this as one fraction using our difference of 2 squares, we've got x plus 5 over 2 plus or minus root 57 over 4. This would be our final answer for this question, and we're done. So again, the maths for these ones is not too different from our completing the square of even numbers, but we can see that it just gets a little bit more confusing, especially when we're using those fractions. If you can use a calculator, please double check your answers for all of these ones. But if not, make sure you are on top of adding and subtracting with fractions, because that would be a really annoying way to lose marks. But again, the skill is, hey, can you recognize that we have to add and subtract half of that middle coefficient? Because once we've done that, we've created a perfect square that we can factorize from.